In this lesson, we are going to learn about the triangle sum, and we're going to use isosceles triangles with that too. And we're going to be able to, at the end of this lesson, solve for missing angles of a triangle, any triangle. So the important thing, and it's something that you probably already know, is the triangle sum theorem. And that says that the sum of the interior angles of a triangle is 180 degrees. The angles of a triangle always add up to 180 degrees. So if I want to use that, so that just needs to like sit. We use that all the time in geometry. So I want to find angle 1 right here. So I want to find the measure of each numbered angle. So I have 62 degrees. This one doesn't have an angle, but it does say 90 degrees because it's a right angle, and all right angles are 90 degrees. And so I want to take that 62 degrees and I want to add 90 degrees. And then I want to subtract 180 minus 152, and that gives me 28. So angle 1 then would be 28 degrees because those three angles together have to add up to 180 degrees. Okay, now in this one has something special. Notice that these are marked the same. That means they are congruent to each other. And as soon as you see that, you want to go ahead and fill in some of the gaps. So we know that that's 30 degrees. So if those two are 30 degrees and the three of these angles add up to 180, then we can take 180 and subtract 60 and get 120. So angle 1 then has to be 120 degrees. That makes that an obtuse triangle. Now, number 3 gets a little more complicated because it has a bunch of pieces. Now, there's a couple of places that you can start, but I think the easiest place to start, the most obvious place to start, is right here with this little triangle. There are actually 3 triangles in that picture. But if you see that 72 and 22, you can take 72 and add 22. So the sum of these two angles is 94. And if you take 180 and subtract 94, you find out that angle 1 is 86. Now somehow you have to get into that other triangle. Now you have a couple of options. You can use this big triangle. So don't feel like my way is the only way. You can use this big triangle where this angle, and this whole angle adds up to 180. So we could take 72 plus 22 plus 30. We've used up 124 degrees of the 180 degrees that we need. So 180 minus 124 is 56. So angle 2 is 56. Now notice I'm labeling it in my picture. I think it's a good idea to label your picture because it will trigger what to do next. It'll help you to know what to do next. And the reason that I want you to see that is because of this right here. See these two angles? Remember what those are called when you have adjacent angles that form a straight angle, form a straight line. Then these two are a linear pair. Linear pairs are supplementary, which means they add up to 180. And so we can take 180 and subtract 86 and find out that angle 3 then is 94 degrees. So angle 1 is 86 degrees, angle 2 is 56 degrees, and angle 3 is 94 degrees. Now, you don't have to solve them in order, even though they're 1, 2, and 3. You don't have to solve them in order, so don't feel like you have to. You could have solved for 1, and then you go, oh, I can see number 3. So you find number 3, and then you could use this triangle, this little one right here, add 94 and 30, subtract that from 180, and get 56, and you would still get that. So you don't have to solve in order, so don't feel like you have to do that. You're stuck. Okay, so let's go ahead and just start filling in our gaps, and then we'll come down here and we'll figure out how to name our angles. Okay, so I look at this triangle, I see this triangle, and I see this triangle. So I notice that this triangle over here has 2 angle measures and it's just missing 1. So I'm going to start here. I'm going to do 66 plus 58. That gives me 124. So those 2 angles together add up to 124. I need to subtract that from 180 to see how much I have left. So angle 1 is 56 degrees. So now this is where we got to go back and think about something else that we know. We know, though, that this angle here, MQP, and this angle here, angle 2, angle 1 and angle 2, are vertical angles, and vertical angles are congruent to each other, so that means that angle 2 is also 56 degrees. Okay, now that we know that, now we have 2 of our 3 angles, so we can do 56 plus 50. That's the sum of those two angles. Subtract that from 180 and get that angle 3 is 74. So let's look, MQN. So MQN is this angle out here. MQN, we haven't found that one yet, but I know that these two angles here or these two angles here are supplementary. They're a linear pair, so I can take 180 and subtract 56 and get 124 degrees. MQP, that's the same as angle 1, and it's 56 degrees. NQO, N to Q to O is this angle right here. It's angle 2, and it's 56 degrees also. And then QNO, here's Q, here's N, here's O. That's angle 3, and it is 74 degrees. Don't forget how to use those proper angle names. Okay, now let's go back and talk about our isosceles triangles that we talked about the other day. So remember that we have every isosceles triangle has legs, a base, and base angles, and a vertex angle. So the legs of this isosceles triangle, DOG, the legs are DO and OG. DO and OG. The legs are the congruent sides. Okay, the base of DOG is DG. Okay, it's the third side. It's the leftover side. It's not congruent. Okay, it's the not congruent side. Now, base doesn't mean that it's sitting on it. Okay, it could just as well be upside down or on its side. Okay, it doesn't matter. This is still the base. Okay, the base is still that piece. It's not where it is. It's not a base like, think the base of a lamp. It's not base like bottom. It's just the base. Okay, so it's the non-congruent side. The base angles are attached to the base. So angle D is the base and the base angle, and angle G is the base angle. And then the vertex angle. The vertex angle is up there in between the two congruent sides. So in this case, it is angle O. Now, here's what we know. We know that the base angles are congruent to each other. The legs are congruent to each other. The base angles are congruent to each other because those two sides are equal, which means these two angles opposite them have to also be equal also. So this is your vertex. That's your vertex angle, and then this is your base angle, and this is your base angle. Okay, so those are your base angles, but they're not always on the bottom, so don't go by that. Okay, so now let's put this into practice. The base angles theorem says if two sides of the triangle are congruent, then the angles opposite those sides are congruent. That's what we just said. If we have a triangle, let me draw it so it looks a little bit different. If I have two sides of the triangle that are congruent to each other, the angles, this angle right here, that are opposite them, opposite means across or diagonal, okay, those are also congruent. So anytime you see that right here, now remember on one that we did earlier, right, this one right here, I had that these two angles were marked congruent. Well, then that automatically tells me now I know that means this is an isosceles triangle. So in this problem, I told you they were equal to each other, but now because of this theorem, I have the expectation that you will remember that those two angles can be congruent to each other when the sides are the same. So when I first look at this picture, I want to solve for x and I want to solve for y. So just kind of pick a place to start. Anything that makes sense to you, I start here. Those two sides are congruent. If those two sides are congruent, that automatically means that these are my base angles and they have to be congruent, which means since that angle is 35, this angle is 35. So every triangle adds up to 180. I have 35 and 35. That's 70, and 180 minus 70 is 110. So angle X is 110 degrees. So now I have to figure out how to get this one. Now again, if these two sides are congruent, then this angle is congruent to this angle. They're not the same as the other angles, so I marked them a little bit differently. Now, I've used up what I know is they're the same, and I've used up 96 degrees. So if I take 180 and subtract 96, 180 minus 96, that means I have 84 degrees left for these two angles. So each of those angles this is what both of them add up to be. So if I take that and divide it by 2, that will tell me how big each one is. So this is 42 and this is 42. So you have to pay attention to whether I've given you the vertex angle or the base angle. The base angle gets doubled. The vertex angle gets used once. So angle X then is 110 degrees and angle Y is 42 degrees. Each of those is 42. So let's look at this one. It's a little more complicated, but what I notice is, yes, I see this big trapezoid, but that big trapezoid has been broken into two separate triangles. Now, there are several ways that you can go about doing this, but the first thing that I notice and the first place I want to start is right there. Okay? Now, we're going to pull a lot of things together that we have learned, but right now what I know is that if those two are congruent, it means that these two angles, X and Z, are congruent to each other. So I've already used up 108. I've used up 110 of my 180. So I subtract 110 from 180 and I get 70. So I take 70 and I divide it by 2 because each of these has to be the same measure. So I divide it by 2 and I get that Z is 35 and I get that X is 35. So I know X is 35 degrees and I know that Z is 35 degrees. Fill it in the picture so that it helps to trigger what you should do next. So now I'm looking at this and I'm trying to figure out where to go next. So I look over here and these three angles, I don't have enough to be able to add those up to 180. There has to be a way for me to go out of these measurements into this triangle up here. Well, there's something that you should have noticed, or you may have noticed, and it's these arrows. If you have information like that, there's usually a reason. So I'm going to highlight these two parallel lines, and then I'm going to connect them with this transversal. I could also connect them with this transversal, but that Z is the one that we use a lot. And so it makes it a little bit easier. Notice this angle right here and this angle right here. If you remember, those are alternate interior angles, and we learned that if lines are parallel, alternate interior angles are congruent. That means that if Z is 35, then W is also 35. So now we know that W is 35. Well, now I can look at this one triangle up here, this bigger triangle. If this is 50 and this is 35, I've used up 85 of my 180. So 180 minus 85 is equal to 95, which means that angle Y is 95 degrees. Again, it's always a good idea to label your picture as you go, write it down, because then it will trigger the next thing and help you to know what to do next. The sum of the interior angles of a triangle adds up to 180 degrees. And anytime you're dealing with isosceles triangles, don't forget that your base angles, which are your angles that are opposite of your two congruent sides, they are congruent to each other. And that will help us to know how to solve for the missing angles.